In this video,
Even in
I'm
here,
going to be
these
talking
Earth snacks
about
are still superior.
Biofilms, and they're basically they're associated with the cancerous tissues or tumor microenvironments, and they're basically like microbial communities that adhere to tumor surfaces or surrounding tissues, and they can contribute to immune evasion, chronic inflammation, and even tumor progression. And they are resistant to antimicrobial or immune mediated clearance compared to normal biofilms. So, hyaluronan can be secreted by or bound by biofilm forming microbes in tumors. So, a good way to reduce that is by targeting the strains that might be helping uh, to form the secretion machinery or secretion locations. So basically what this does is it acts as a protective layer, reducing immune system recognition, even promoting angiogenesis, which is the growth of blood vessels, leading to chemotherapy resistance. But the chemotherapy isn't good to begin with, anyways, because chemotherapy can have negative consequences. The reason hyaluronic acid can promote tumor growth is because hyaluronic acid can enhance a local inflammation, and tumors and cancer cells that they happen to gravitate towards the inflammation, or they grow from inflammation. So oncobiofilms can be embedded in hyaluronan, and they may shield microbial antigens from immune surveillance. And hyaluronan can even bind to CD44 receptors on immune and tumor cells, modulating immune responses. There is a way to target hyaluronan, and that is with hyaluronidase, and that can disrupt oncobiofilm structure, which can improve drug penetration and enhance immune recognition. Okay, the STAT3 pathway, which I've talked about a lot in some of my other videos. Also, STAT3 is one of my main focuses in most of my videos. So STAT3 actually is heavily involved in oncobiofilm formation, as well as upregulation of CD44 expression. When CD44 is expressed, hyaluronic acid actually binds to the CD44. So STAT3 leads to tumor survival signaling and immune evasion as well. Now, pineapple, which I have mentioned in many of my videos, contains bromelain, and it has been shown to reduce phosphorylation of STAT3. So that shows that pineapple can help reduce the formation of oncobiofilms. But pineapple is not the only thing that can do that. Pineapple also decreases IL-6 signaling, which is a major STAT3 activator. So anything that can downregulate or decrease IL-6 will also decrease oncobiofilms. And I know many fruits that can reduce IL-6. Now, a pineapple is known to cleave CD44, but there is no direct meaningful evidence that it has an effect on the following, which is, so CD44 is the principal HA receptor. HA is short for hyaluronic acid, which is involved in oncobiofilms. So hyaluronic acid, it actually binds to CD44. What this ends up doing is that it activates STAT3, which is going to activate oncobiofilms, therefore driving migration and metastasis, supports biofilm-like tumor architecture, and then tumor cell adhesion. Okay, so hyaluronic acid can also accumulate, or it's rich at the extracellular matrix, or ECM for short. So that's pretty much where the immune cells, where they have to enter to attack cancer cells. But a bromelain can disrupt ECM scaffolding proteins and reduces integrin cooperation, which could mean that this also disrupts hyaluronic acid rich paracellular matrix at the ECM. Now, these biofilms, they actually have an effect or an impact or a connection with the iron axis and iron exporters. So what happens is the biofilms, they secrete hyaluronidase, and then this releases lipopolysaccharides, which is a gram-negative bacteria. And there's like different kinds here, but they're hard to pronounce. And these gram-negative bacteria, or LPS, they activate toll-like receptor 2 and toll-like receptor 4, leading to NFKB activation and then IL-6 release. The problem with IL-6 is that it upregulates hepcidin and then leading to the degradation of ferroportin. What this ends up doing is that the iron ends up getting trapped in macrophages. And I've talked about this in some of my other videos. This ends up leading to the M2 polarization. Basically, it's a phenotype that supports tumors. Tumor cells are iron enriched. That's because tumors, they can access the iron trapped in the macrophage. Also, microbiome, they even compete for iron and they release cytorophores. Okay, so now to the part of the video of reducing the negative effects or impacts of the hyaluronic acid binding to the CD44 or the CD14, or no, the toll-like receptor 4, because that released the um, lipopolysaccharides, or the gram-negative bacteria. So reduce the endotoxemia and improving the gut barrier integrity. There are dietary tools such as omega-3 fatty acids, so can be found in sardines, which is one of my favorites. Also, omega-3 pills or supplements could possibly work. Even polyphenols such as quercetin. Uh, you can find quercetin in apples and grapes, and then EGCG in green tea. So the goal with these foods and compounds is to reduce the hepcidin drivers. So the hepcidin are basically what are degrading the ferroportin, and as a result of that, the ferroportin cannot export the iron out of the macrophages. So the iron continues to stay stuck in the macrophage because the ferroportins are responsible, or their role or function is to export iron out of the macrophage. But of course, that can't happen, or that cannot happen if hepcidin is degrading the ferroportin. Okay, so quick recap. The oncobiofilms, they are created by hyaluronic acid, and tumors and cancer cells, they use that as a shield that can even get thick. The shield ends up resisting against chemotherapy, but and even destabilizes immunity. Hyaluronic acid, or hyaluronidase, can bind to CD44. Pineapple happens to cleave it, but pineapple cleaving, it doesn't seem to have any meaningful effect on the binding to the CD44. And the hyaluronidase can also interact with the toll-like receptor 4, creating lipopolysaccharides that ends up inducing hepcidin, which degrades the ferroportin and then the iron gets trapped in the macrophages. So that's it for the video. If you want more future videos, then like, comment, share, subscribe, and I'll see you in the next video.